Hi, algebra students. In lesson 7.4, we're going to look at how to select and draw conclusions from samples. So take a look at our notes for today. A population is a group of people or objects that you want information about. When it's too difficult, time-consuming, or expensive to survey everyone in a population, information is often gathered from a sample or a subset of the population. For instance, there's all the presidential campaigns going on right now, and people are constantly getting phone calls and being polled on which candidate it is that they support. Those are samples. It's not like a polling company is going to call every single American. Instead, they're going to call a certain number of them and hope that they answer and hope that they respond. From that sample, they'll put together the numbers that you might see on CNN or Fox News or MSNBC or whatever it is that you might watch. So, a couple of different ways that you can take a sample. The first one would be a self-selected sample. In a self-selected sample, members of a population can volunteer to be in the sample. So in the little diagram you see, a couple of these people raising their hands saying, hey, I'll be a part of this sample. So self-selected, you choose to be a part of it. In a systematic sample, there's some particular rule used to select members of a population. In this case, every other person. Okay, not this person or this one. Yep, no, yep, no, yep, no, yep, no, etc. So every third, every fifth, every 10th, whatever it is, a particular rule make for a systematic sample. In a convenient sample, we take some easy to reach members of the population. So the first 4 people that walk by, the first 10 people we run into in the hallway, the first row of an audience, whatever it might be, that would be a convenience sample. I can conveniently ask these people whatever question it is that I'm trying to ask. And finally, in a random sample, we have actually a true random selection. That means that each member of a population has an equal chance of being selected. Ways to do that would be like drawing names out of a hat, or a random number assigned to everybody. So we'll look at a couple of those in a little bit. So taking a look at an example, the manufacturer wants to sample the parts from a production line for defects. Identify the type of sample described. So the first method, the manufacturer has every 5th item on the production line tested for defects. Well, if it's the every 5th item, that sounds like a systematic way of doing things, so I would say that is a systematic sample. The next one, the manufacturer has the first 50 items on the production line tested. That seems like a pretty convenient thing to do, to just grab the first 50, so I'm going to call that a convenience sample. Okay. Now the next thing we're going to look at is sampling with the idea of bias included. So, as our notes say, in order to draw accurate conclusions about a population from a sample, you should select an unbiased sample. An unbiased sample is representative of the population you want information about. A sample that overrepresents or underrepresents part of the population is a biased sample. Now you might think of this as the term bias, meaning you lean very heavily towards one thing or another. Well, we want accurate conclusions to be drawn from samples that come from an unbiased group of people. So take a look at these examples. The makers of an application for smartphones want feedback for their product. They ask you, the user, to rate their application. Tell whether the sample is biased or unbiased. Now you could probably argue either way on this one, which is why the word explain is tagged at the end of this particular sentence. So I'm going to say that this would be a biased sample, and I'll tell you why. I would say, thinking back to any time you've ever had an app pop up with the, give us 5 stars or 4 stars or rate my app, you've probably ignored it, to be honest. I know I ignore it most of the time. Now, if you have given a rating, it's probably because you absolutely love that app and you're going to give it 5 stars, or you think that app is total garbage and you're only going to give it 1 star. I'd say people who are like, meh, this app's okay, probably aren't going to spend the time to actually rate the app, which is why I would say this is a biased sample, because you're only going to get people with really, really strong feelings. Okay, so only strong feelings respond. Would be my quick explanation of that one. The next one, Mr. Willems wants to know if students would like the morning announcements posted on Moodle. He surveys students in his programming class. Identify the type of sample used and tell whether the sample is biased. Well, first of all, if Mr. Willems teaches programming, I would say that this, if he wants to know if students, being like the general student body, want to know if should we post announcements on Moodle. Well, if he asks the kids in programming, that seems to be a pretty convenient thing for Mr. Willems, because that's the class he teaches. So I'll call it a convenient sample first of all. Now, is it biased or not? Again, you could probably argue one way or another. I'm going to say this is biased because kids in a programming class probably enjoy the computer and probably wouldn't mind having the announcements just on Moodle instead of having to listen to them over the loudspeaker. So I'll say biased because you're talking to computer kids who just naturally lean that way. It's not a good representation of the entire student body. Last one. You remember student council. You want to poll Shoreland students to find out whether or not they want the homecoming dance to be held on campus or at a special location. There are 300 students or so at Shoreland. Describe 2 methods for selecting a random sample of 40 students to poll. Well, the one thing that's truly random that I mentioned before was you pull names out of a hat. If you put all 300 students' names in a hat and you just pull them out one by one, that would be truly random. Every name would have an equal opportunity to be pulled out of that hat. Another way to do that would be to assign everyone a number, all 300 some students, and assign each student a number, and then use some sort of random integer generator. Running out of space here. Now, a random integer generator, you could maybe use your computer to come up with a random number, like this Smart Notebook file has a random number provider. Your calculator's got a kind of neat feature like that too. If you go to the math menu on your calculator, skip over to probability, which is this one. This 5th option, rand int, that means a random integer. So if I were to choose that option, let's say I want a random integer from 1 to, 300, because there's 300 students, let's say, and n is the number of random integers that I want. I want 40 of them because I want 40 people for my poll. So whoever's number comes up from the random integer generator, that's who I'm going to ask about the homecoming dance location. I'm going to hit enter to paste it. It just brings it out here. So 1 to 300, and pick 40 of them. And I hit enter, and it takes a minute, but it spits out 40 some integers, and I can scroll left and right and take a look at all of these if I really want to. So hit enter, take a look at them. Maybe I want to store them in a list where I can look at them. Let's say I store the previous answer as list 4, let's say. Hit enter. I go check out list 4. Oops. That's that edit. List 4, here we go. There's my list of random integers. So person number 122 and 221 and 14 and 102, those are the people we're going to ask our question. That'd be a completely randomly selected sample. Pretty good deal.